Hi, welcome to the first SAS. We started from SAS X0, not SAS X1. This is uh, the first SAS, not the zeroth SAS, and it's about epistemological cartography. Let's get out the etymology of the stuff. I'm thinking of creating some merch that just says etymologically speaking, ellipsis, dot dot. But yeah, epistemology is just the philosophical theory of knowledge, and cartography is map making. So, charting domains, building knowledge graphs. This is what this is about. And rather than just going out with knowledge graphs right away, truly understanding the structure of knowledge, truly understanding how knowledge is distributed across domains or related across domains or structured as a whole, how it is laid out as a whole, how the terrain of knowledge is laid out. That's what this is about, epistemological cartography. Uh, I'm 25 right now. I just turned recently on the 1st of May I turned 25. Uh, what what has been sort of I've all okay. As humans, we do tend to specialize quite a lot when we're younger and when we are out there in the system, education, exams, that sort of stuff. We do specialize and do stuff like that. But then I read a book when I was 19. It was by Walter Isaacson, the biography of Leonardo da Vinci. And that's when I was exposed to the concept of a polymath or a Renaissance man. And that is when my perception of knowledge, my perception of application of domains was sort of turned inside out, and that is sort of a turning point in how I perceive things. That was a turning point in how I perceive things. It was more about first of all, I got pretty ambitious in terms of my own knowledge pursuits. So reading that motivated me a lot to sort of become my own version of a polymath and explore things with depth and breadth and be able to apply them practically across domains. So that's one thing. How it helped me think about knowledge philosophically, its structure is more along the lines of it made me wonder, is polymathy really possible in the modern day? Because the research that we do right now is very specialized. To sort of be at the frontier of a domain is a very involved task. Uh, that's why I do fantasize about being in the 15 or 1600s sometime, because you could sort of contribute in a lot of domains, because things were still pretty close together. Science was still young. The scientific method was still being refined. Uh, Community and societies around it was still being formed and they were maturing. Right now, it's already pretty saturated and mature the way science is done right now. So to actually to actually make a meaningful contribution, that's what differentiates the polymath from a 1500 polymath and one today. They could make practical contributions towards disciplines, uh, and a wide variety of them. So that is the current state of how domains have evolved. They've grown, they've matured, and you have to be very specific in how you contribute now. So the older strategy of just observing and maintaining journals. So my first way of charting out things and my thoughts and all of that was flowing journals. I maintained a lot of journals. I just used to jot down anything that used to come into my mind. And what I did was I had a lot of observations. It did clear my mind. It did give me a lot of ideas along the way. Uh, that lasted for a while, but then that was not reliable. Uh, it was sort of a write-only journal. I could not extract value from those journals, let's say if I'd written something a year or 2 years ago, I would not I would not be able to extract value from that. So the notion of structuring my knowledge better came in. The need to structure my knowledge better so that I could rely upon whatever taken notes of, and I could I could recall it and stand upon it for future thought sessions and future domain explorations is what that's the need that arose. So that's when knowledge graphs come in. So you would initially start out with linear notes. I started out with simple markdown files and one a directory, just a directory of notes, a flat file hierarchy, but no links, no links. So just project based separated out notes whenever I was working on a particular project, the notes for that particular project in that directory itself in just markdown, and I used to edit them with Vim. So it was all snappy and good, and the locality of reference, that sort of helped out in uh, it being helpful. So whenever I was working on that project, I had everything handy. Uh, but yeah, that was again, it limited cross project transfer. So that was another need that arose, to be able to think irrespective of what project you're working on for that domain, to be able to invoke the insights of that domain without having to dive into the project that you were working on while on that. So that calls for generic notes, that calls for generic whatever is happening in the second brain world today. That's what that is. So that could be your Obsidian, or what I do in org room, or just roam, or any graph building knowledge system that you have. So that's what that is, building knowledge graphs. Right now again, so that with knowledge graphs, you the knowledge graph sort of evolves based on your tendencies. So this is where this is where sort of technology is dependent on the mindset of the user. So a knowledge graph, this is where it sort of starts becoming evident, in the sense that it can be visually explored right away. So based on the mindset of the reader, of whatever he or she is consuming, and putting it out there in the knowledge graph, the way he or she is thinking, it can be observed in the knowledge graph. That is not quite possible for say immediately. That is not quite immediately possible in the larger span of things in a journal, or just a project-oriented system of notes, a separated markdown flat file hierarchy in projects. So the knowledge graph, that is the first sort of explicit abstraction or entity that sort of has helped me. Uh, that has made me think about the structure of knowledge forcefully. The knowledge graph. For there are it's a mathematical tree. It's a tree in the sense, it's a mathematical graph. There's nodes, there's edges, there's properties to those nodes and those edges. They can be either unidirectional or bidirectional. Nodes can have tags. Nodes can have yeah, subnodes. So there can be a parent-child relationship. So it can be a tree as well. Uh, yeah, subnodes don't link back to the parent, but then parent does lead back to the subnodes. Or you could have it the other way around, that the subnodes only lead to the parent. So it's sort of a tree as well. And of course, nodes can be connected, so different trees can be connected. So that does form a graph. And this gives rise to a whole sort of network dynamics. So knowledge network dynamics. That is something that arises out of this. So there's this notion of arising. Whenever you give something some form and you assign some constraints as to those nodes and edges, and the rest, you sort of constrain the growth of entropy in certain directions. There's a whole bunch of emergent behaviors So these emergent behaviors, when thinking about knowledge graphs, could be, let's say, you could have the application of traversing nodes, traversing links to kind of find connections in a meaningful manner, or just scrolling across your graph, walking your graph. Or another interesting emergent behavior in any very large knowledge graph, knowledge graph, let's say Wikipedia, is that whatever node you start out with, there is a way to reach to philosophy. So philosophy can be taught philosophy can be selected as a root of the whole tree, and you could still reach all of knowledge. So anything that you start out with, it could be linked back to philosophy. So that's sort of an emergent behavior. No one sort of set that constraint. No one set that constraint that it should link back to philosophy. There should be a valid part to philosophy. It wasn't set when building a knowledge graph. It emerged. So these sort of emergent behaviors sort of arise in. That's when you get into the territory of observing science itself, applying science on science itself, observation, scientific method on science itself, observation and stuff. So that is where things sort of get more interesting. Why do you do all of this? To answer that question of is it really possible to be a polymath? I mean, you should do you dare to become a polymath in this era? In this era of hyper specialized frontiers of domains, do you think you're capable of getting into that? Because specializing into one thing in itself is going to be really difficult compared to, say, 500 years ago. Uh, but let's say having meaningful contributions that are equally potent across, let's say, two domains is like an exponentially more difficult thing than doing it in just one domain. So it calls for a completely different way of thought about knowledge. So I'm hypothesizing I hypothesize it couldn't be equivalent to iterating over the same domain again and again and specializing on it if you wanted to do it across multiple domains, because context switching is sort of very difficult. So when you jump from a subgraph to another subgraph in your knowledge graph, there's going to be a whole bunch of context switches, and the larger the context switch, the slower your growth, the slower your progress, and that makes it all the more difficult. So just adding more stuff hinders the growth of the initial one, and that is what people call as you not being focused. So all the polymathic is not a word, but yeah, all the men, all the women who are into polymathy in this world, they get the tag of a dilettante, sort of an amateur, if they're not focused enough, quote unquote, focused enough. That's what that arises in. The jack of all trades, master of none. But then that's sort of an incomplete quote. Still better than the master of one. Is sort of the whole thing. But that's besides the point. What I want to say is this realization that domains right now, frontiers right now, are different, calls for a rethinking of the whole knowledge approach, the whole specialization approach. Uh, to discretize domains, to think that they are separate, is sort of holding yourself back based on assumptions that were made centuries ago. So why not think of knowledge as a whole? That's where epistemology comes in. Epistemology, the philosophical theory of knowledge, just is an enabler, towards polymathy. It would help you sort of realize the true limitations or true opportunities and true potential of wanting to be a polymath in this age. Because I think the older approach is not quite feasible right now. If you, how do you define a polymath right now? Let's set a definition. Someone who has meaningful contributions, meaningful in the sense that praised, societally praised contributions in multiple domains, not just a hobbyist. Uh, yeah, so you have to be at the peak of your domain, at peak in the sense, at least at a very high percentile. not something that can be easily achieved by an average person with few hours of efforts. It's not just that you're interested in multiple domains, so you dabbled a lot, you got pretty good, and then you just stopped. That's not the way I judge a polymath. It's more based on if you can have meaningful contributions that society has collectively acknowledged was meaningful, and yeah, and rewards it in different ways. Could be awards, could be, yeah, you could either have practical success in it. You could have a business around stuff. So yeah, that's what it is. And epistemology sort of helps you realize the opportunities, the potentials of wanting to be a polymath in this world, choosing to map it all out when you're studying anything. So all of us, given that I was born in 2000s, I was born in the year 2000. So, and I'm an Indian. I'm an Indian. So I do have I did have that initial push towards engineering or a specific field. Of course, I do like engineering. I did choose it on my of my own volition, and I do enjoy engineering and computers a lot. Uh, but the point is, a lot of us have gone through the conventional education system. Uh, Most of us haven't been homeschooled or haven't had the opportunity to choose our own schooling systems. We were not mature enough for that, so the adults around that decided what we should, what are at least how we should educate ourselves, at least in our initial years, and that is necessary, of course. I mean, we're not wise enough to think for ourselves pretty early on. There might be a few exceptions here and there, but the average person is not mature enough to think to design their own curriculum. So, uh, by the time you sort of become aware of this urge of yourself to sort of, let's say, learn everything, or it's rooted in curiosity. Uh, I'll not take a philosophical angle at this right now, but then also rooted in power to know everything, to know a whole bunch of things is also rooted in power, not just curiosity. Uh, I'll do that in some other video. But so by the time you sort of begin begin searching for power, begin seeking power, you're you're a little older than when you were actually learning the most. So for a lot of people, it'll probably start in their late teens, uh, seeking power through knowledge or being more powerful. It sort of starts late. Initially, it's very rare that it starts early. Those are the rare cases, and yeah. So because it starts late, you have already been conditioned to think about a lot of domains a certain way. So you think science is science, you think psychology is psychology. You probably have thoughts about hard sciences and pseudosciences, the scientific method, something that is not rooted in rational thought, or something that is beyond your perception of your current route, which could be, let's say, science. You might think that is irrational. Uh, what helps break this or shatter this is the concept of anthropology. So trying and understanding how human cultures evolved over time, and seeing how domains evolved, how subjects evolved, how knowledge in itself came to be, how things around you have been engineered or thought about, discovered, invented. It sorts of helps you understand the malleable nature of knowledge. Of try to think of it more as a fluid, sort of a malleable fluid. I mean, I don't know. Rather than with a malleable fluid with intra connections, a lot of intra connections. So rather than discretized cubes, that's what it is mostly. So, what this leads to is the importance of thinking at a higher level than just your base hard sciences or pseudosciences, to abstract them a little. And that's where epistemology shines. That's where analysis of knowledge itself is helpful to really understand what you want to get into. So this is not something you study explicitly. You're not going to go ahead and study epistemology right away. You will have to spend time with a whole bunch of domains across you, and you start realizing patterns. Patterns like a simple pattern being everything leads back to philosophy in the Wikipedia graph, or that all the sciences rest on the scientific method. Yeah, or uh, yeah, or the nature, the evolving nature of these domains in itself, compared to, okay, the evolving nature, uh, or the perceptions that sort of differ in how we see these domains. For example, a lawmaker, someone who's been engineering physics laws, let's say Kepler or Newton or Einstein, they'll run thought experiments. They'll think of physics or the sciences as something to be grasped. But then the usual applier, the usual rational person will think of it as laws, as limitations. They might invoke upon science when they need to check the feasibility of a certain thing. I mean, how fast a human can run, or yeah, that sort of stuff. That's where they invoke upon laws of physics or biomechanics or observational stuff. But then when a person like Einstein or Newton or they think about it, they'll draw upon observations, try to make connections. They go about it in a pseudosciencey manner, not a hard science manner. They will challenge existing assumptions. They'll bring together all observations in an agnostic manner, in the sense that without assumptions, without there'll be the concept of a null hypothesis, uh, but they'll test that hypothesis and they'll verify it, and there's no faith or belief or acknowledgement that this is law. That is what differs in how we think and how they think at the root. So, to be able to challenge existing domains and to be able to understand there's a whole bunch of play in anything that is sort of seeming hard right now, to turn foundations upside down from time to time. That ability is when you begin to explicitly see knowledge from a higher level. You sort of leave that plane of hard sciences and pseudosciences, let's say the liberal arts and whatever, get a level up into epistemology and start seeing stuff from the top. That's when you start realizing how domains behave, how they evolve, how they connect, how they are separate. So a very good meta domain for such. So meta domains, the concept of meta domains now comes in. Uh, so physics is not a meta domain; it's sort of a domain. Metaphysics is a sort of a philosophical sort of way to think about anything. Systems thinking is sort of a engineerable way to think about anything. For example, the DSRP framework to think about any of the systems out there. So restrictions between the system, the ecosystem, the systems themselves, R being the relations between those systems, and P being the perspectives that 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 differ when you see the system from different perspectives, from different orientations. So the DSRP framework or systems thinking in general uh, is sort of a meta domain. Another such meta domain could be mathematics. Uh, Mathematics in itself is very abstract. Uh, its potential is only realized when you apply it to something. Uh, 2 plus 2 doesn't mean anything in the practical world unless it is 2 protein bars plus 2 protein bars, or unless if it's applied in finance, or uh, the area under a curve is doesn't mean anything in this practical world unless it is applied to something like, say, computing the distance traveled when you integrate the mod of velocity uh, at each infinitesimal periods of time. Uh, so these concepts, they are abstract and they are a meta domain, and they're only useful when applied to sort of a lower domain. These meta domains sort of help you shatter walls, help you. They're sort of like interdimensional bridges, or yeah, they're kind of they're kind of they'll help you they'll help you understand things in a way that you could not grasp being at this lower basal plane of hard sciences and just immediate observations, to be able to extract patterns out of that. So programming, algorithms, data structures is sort of a meta domain. And where I'm getting with this is each one of us conditioned to go through the education system or get educated in a particular domain. At least the majority of us go through it until 18, 19, 20. To be a polymath, or to want to be a polymath, has to be a very explicit decision. It has to be sort of a very involved one, in the sense that you have to battle your own internal questions to yourself, skepticism, all of that. If you would be able to handle it, if it is valid in itself, if it is, of course, there's proof out there that people have done it. But then there's, of course, this case of today is special. Today is special in the sense that the present is special. So, what this leads to is this explicit acceptance and this departing on a journey, on the adventure of being a polymath. That sort of polymath, not a polymath. That sort of invites you into this world of meta domains to understand them better. If you really want to be good at a whole bunch of things, so unless you sort of understand these meta domains, okay. So to think about it, think about them being higher, then these might be sort of misleading. Let's say they are more foundational than the hard sciences themselves. Foundational in the sense that the way you think, uh, they are the foundation of the present cognitive infrastructure. And yeah, so these metadomains is what sort of helped you towards understanding your higher domains better. So, and there's a hierarchy in the sense that there's a there's a class of metadomains as patterns anywhere you go. Things can be abstracted out into generic representations anywhere you go. So, for example, systems thinking could be applied to a biological organism, how the organ functions, how it takes actions based on, say, releasing hormones, or how it restricts blood here and there. Uh, yeah, I mean, let's say based on external factors, based on temperature, uh, your veins could contract, or they could pull blood away and out, that sort of stuff. The control factor out there, and your control center being the processing stuff and everything, how it takes action. That could be a systems thinking application in one domain, and it could also be sort of an application in, say, electronic systems, electronic digital systems, being a very explicit, where the input is a signal. Your system in itself has a nature, it has a state, has a configuration that transforms the initial input state into another state. So that is a very basic system. The composition of these systems yields another system. And it gives rise to a whole another branch of abstractions, like say feedback loops, that sort of stuff. So these sort of lay the foundations of your cognitive infrastructure, how you think, how you understand stuff. And unless you explicitly address these and invest time into them to get good at them, you might have a hard time understanding epistemology, all of knowledge, the philosophical theory of knowledge, to philosophically theorize about it. It would be sort of difficult, to say the least, if you're just relying on observations and do not take notes and do not chart your way, do not map your way. So, if I really want to engineer cognitive infrastructure, the first step in whatever I do is having logs and charting out stuff in a meaningful manner, in a flexible manner that I can use it later. And that's what I've been doing personally for a while as well. But then I have initiated a map for these metadomains as well, these generic things as well, in the concept of in under the GitHub of Cornware Industries, the cartograph. It is sort of an epistemological cartography initiative where I just map out stuff. And these knowledge graphs, okay, so I have a background. My initial specialization domain was computer science and AI. So I have a background in sort of representing knowledge, trying to represent knowledge better. I do have some background in that, and to apply that on metadomains is something that could, yeah, AI is also sort of a very practical metadomain in the sense that it could be applied anywhere, and yeah, it helps you think about patterns in general. So pattern recognition and representation is a very fundamental domain. Patterns exist everywhere if you zoom out enough, or if you zoom in enough. Patterns do exist everywhere. Uh, uh, there's also chaos everywhere. So chaos theory or randomness, the nature of or probabilities, or just things being chaotic, is also sort of a fundamental domain. To invoke upon these on different hard sciences is an intellectual privilege and sort of a eureka that you should want to experience. So yeah, yeah, that's why you should sort of have a cartograph of your own, of an initiative to chart out whatever you think, to sort of challenge assumptions, to sort of think about things in a more abstract manner. Whatever way you think is good, could be from a higher level or a form from a more basal level, whatever you think is good. Uh, yeah, try doing that. So link is going to be in the description. Uh, yeah, the epistemological cartograph. I have just restarted that, and that will sort of be a foundation for a whole bunch of things that I talk about. You of course have heard of the Zettelkasten. I mean, if you're watching videos like these, you know what a second brain is, what a Zettelkasten is, and yeah, this is just an application of that at an abstract level to metadomains, and to identifying the larger pattern in this philosophical landscape of knowledge. So, wisdom about knowledge itself. That is what we are seeking, because that's what lays the foundations of cognitive infrastructure. And yeah, I think this SAS was fairly dense. We could end it here. Uh, yeah, cool. So let's move out. So this was the Bitmage, the founder of Conware Industries. I do these sort of videos to sort of channel my epistemological self. I do have a technical side that I geek out as well. At thebitmage.com, I do have a YouTube channel as well. They are our partners. Do check that out in the description. Here, I talk about stuff like this, and this is a series. So do check out the first one, the SAS X0. I encode my series in hex. Uh, yeah, you could sort of treat it as a podcast or try watching me on a television doing stuff with my hands. I'll probably involve more of my hands and get into a landscape mode soon. So, uh, yeah, trying and explaining stuff. I could honestly also maybe start drawing things. I could get a whiteboard or something. I think that would also be helpful. So, yeah, we'll evolve. We'll converge into a better representation, a better abstraction of conveying these over time. But yeah. Do subscribe if you're interested in understanding the generic cognitive infrastructure at a personal, at a planetary scale. Do check out conver.com, do check out thebitmage.com, and yeah, thanks for tuning in. See you in the next one.